Okay, YouTube, in my last video we discussed how to multiply numbers, complex numbers that is, that are listed or at least written in trig form. And in this video we're going to discuss how to raise to a power a number that's written in trig form, which is actually kind of, if you think about it, an extension of a product. It's just a product with n number of factors, that is, given some z to the n or some complex number to the n. We're taking it times itself multiple times. So it makes sense that we would follow up with this video, but there's an interesting law, actually a theorem, that is DeMoivre's theorem, So just kind of fun. I can show you Abraham DeMoivre, but that's this guy right here. And actually he developed this theorem that basically says this: if you have a complex number z in trig form, that is, recall trig form recalls two pieces of information, just a length or a distance from the origin and some direction and standard position that you're headed in. But we say, given this number r cosine theta plus I sine theta, and n being an integer, then we can say this. We say z to the n is equal to this. Basically, what we'll do is we'll take the modulus, or the length of our vector, to the nth power, and then what we'll do is we'll still say cosine theta plus I sine theta. It's just that we will take that nth power and multiply that n by the argument. So whatever the direction was, we'll just take it times n. And an abbreviated form of writing this would be basically the modulus to that power, as we've already said, times cosine I sine n theta. So this is like really easy to do, and actually we're just going to go ahead and demonstrate this here. We're actually going to just demonstrate it with a number that's already in trig form to illustrate the simplicity of doing this. And then we're actually going to do this with a number in standard form and talk about the intent of why would I want to use DeMoivre's theorem when raising a complex number in standard form to a power. So let's go ahead and take a look at our first example here. We say, let z equal 3 cosine I sine 40 degrees. Okay, so we already have our modulus, which is 3. We already have our argument, which is 40 degrees. And recall that I think it's good to review this. This is just some number we're saying is headed in a 40-degree direction, which is about this. And we're saying we're going 3 units out from the origin. That's this number here. So we say r equals 3. And we're heading in a 40-degree direction given the angles in standard position. So anyways, that being said, let's go ahead and use DeMoivre's theorem to find this number raised to the 10th power. Excuse me. So according to this theorem, we'd say z to the 10th power would be equal to our modulus to the 10th power. So we say 3 to the 10th. Let me go ahead and rewrite that there. 3 to the 10th times cosine I sine of 10, which is our n, times 40 degrees. So simply put, we get 3 to the 10th, which actually we can go find on a calculator here. We say 3 power of 10, can't be that big. 3 power of 10, 59049. So 59049 is the new modulus on this vector. It's really large, and we say times cosine I sine of 10 times 40 degrees, which is just 400 degrees. Okay. So now, this is quite technically accurate, but one thing that needs to be said is simply this. When we talk about a number in trig form, that is, you're giving a direction in standard position, we say that theta, the argument, is typically the smallest positive angle that would get us to this. So if you consider a 400-degree angle, 400-degree angle would be 40 degrees past 360 degrees here. Okay, the smallest positive angle that would have given this angle, which is a 400-degree angle, is actually 40 degrees. We could actually say, instead of saying 400, we could say 40 and mean the same thing. So it is entirely appropriate that if you have this on your paper right here, first of all, you're correct. But second of all, that we actually just rewrite this as 59049 cosine I sine 40 degrees. And again, the intent of writing just 40 degrees is because we just want to use the smallest positive angle that gets us to that part. And 400 degrees is coterminal with 40 anyways, so we'll just use 40. And one thing they say in general is basically this, that our angle theta is always between and including 360 degrees and 0. Cool, man. So hey, let's talk about this now. What if I had z was 1 plus I? We'll keep it really simple, but 1 plus I, this is a number a plus bi form, or standard form, is not in trig form, so currently we can't use DeMoivre's theorem to raise it to the 10th power, but what I want to do is I actually want to raise this to the 10th power. So let's imagine, let's fathom this here. If I had to find 1 plus I to the 10th power, that is, not 1 to the 10th plus I to the 10th, this is really 1 plus I times 1 plus I times 1 plus I times 1 plus I. It's a product with 10 factors of this. So not only do you get to FOIL, you get to FOIL on a grand scale, like over and over and over. You're going to be miserable, basically. So in order to find z to the 10th, it is actually most convenient to convert it to trig form. and then raise it to the 10th power using DeMoivre's theorem. So, that being said, let's go ahead and work on converting this to trig form, which means we need two things. We need r, and we need our argument theta. So let's go ahead and start by actually illustrating this. We say this number 1 plus I would go 1 to the right on our real axis, 1 up on our imaginary axis. We say it's this number right here. And actually this complex number is expressed by a vector. So we say this vector has an argument r, but we know that we can make a right triangle as. We say 1 and 1. We can find r. Recall that r would have to be x squared plus y squared, the square root of that. This is one thing that you need to memorize when converting from standard to trig form. So we say r in this case would be the square root of 1 squared plus 1 squared, which is 1 plus 1 on the inside of this radicand, which is the square root of 2. And we're perfectly okay with leaving our argument as an exact value, radical 2, instead of like 1.414 or whatever. But now we need to find the argument. Okay, so we say the argument. Now the argument is this smallest angle theta in standard position. That gives us to this direction. So we could say, well, the tangent of theta would be 1 over 1. So now this other formula we're often using to find the argument is tangent of theta is y over x. We know this. So we'd say theta, or at least theta party hat, or reference angle theta, is tangent inverse of y over x. So in this instance, we could say that our reference angle is tangent inverse of 1 over 1. So tangent inverse of 1. And of course, we only ever get a tangent value of 1 when we're dealing with a 45-degree reference angle. So now, what I'd like to point out is this, that our reference angle is 45 degrees, and that actually is our actual argument, theta, in this instance. And the reason why is because, well, we've already graphed this. We say a 45-degree reference angle in the first quadrant is actually its own reference angle. So we say now, we have the argument, we have the modulus, or the length of our vector. So these things can give us our original number 1 plus I as a complex number in trig form. So we say z to the 10th would be the same thing as we want to raise radical 2 cosine I sine 45 degrees to the 10th. And according to Abraham DeMoivre, what we get is this. We get radical 2 to the 10th power times cosine I sine of 10 times our argument, which is 45 degrees. So let's write a few things out here. First of all, radical 2 to the 10th, that is the same thing. I do want to list it this way. Sorry to do some math here. I'm not sorry to do this, as a matter of fact. To the 2nd to the 5th. And the reason why I say this, cosine I sine of 450 degrees, fix that 0 there, is because radical 2 squared to the 5th is still radical 2 to the 10th, but we say radical 2 squared is just 2. So 2 to the 5th, really. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So this is 32 cosine I sine 450 degrees. Now recall, we said that our argument is often, it's always the smallest positive angle that would get us to this direction. So we say 450 degrees, that'd be like 360 degrees, right? Plus another how many? So 360 plus another 90. So we want the smallest positive angle that would have gotten us to this, and the smallest positive angle that would have gotten us to this terminal ray or terminal vector or whatever would have been 90 degrees. So we can say this. Essentially, this is the same thing as 32 CIS 90 degrees. Now, if my students had written 32 cosine I sine 450 on their paper, I would write, oh, you're totally right. It's totally right. But I'm a picky guy, and actually I should be picky. We should be technical. You should be converting that 450 to 90. So just keep that in mind, but this is a quick overview of DeMoivre's theorem for raising complex numbers in trig form to a power. So enjoy.